Well, hi, boys and girls. How you doing? I hope you've had a good weekend. We're going to do rational inequalities in today's video, and I'm going to show you how this is going to help you with answering some questions about your graphs, and it's really going to help you answer a question, like behavior near asymptotes. Sometimes you want to know, does your graph do a U or does it cross over, or what quadrant is it in? So I hope class went well on Friday. Missed you guys, but I'll see you tomorrow. So anyway, let's take a look at what I mean by rational inequality. Let's have x minus 3 over x squared minus 1. And let's see when this graph is greater than, or let's just do greater than 0. Okay, similar to what we did in the video with polynomial inequalities, what we're going to do is we're going to take each factor and we're going to set it equal to 0, and we're going to draw this little number line, and we're going to do some test values. So what I'm going to do first is, of course, factor the denominator. So that's a difference of squares, so that's x plus 1 times x minus 1. And I want to find out when this is greater than 0. So what we're going to do is we're going to take every single factor we have on the top and bottom, and we're going to get these little test points. So if we set all of these equal to 0, we're going to get these important points: x equals 3, x equals 1, and x equals negative 1. So let me see if I can't draw a little line here. Let's get here full screen, and we'll draw ourselves a little line and do the same thing we did with the polynomials. Alright, so there's our line. Go back to blue. No, let's go back to purple for Kelsey. Alright, so I'm going to have negative 1, and then 1, and then 3. And then out here to the left, I've got negative infinity, and out here to the right, I've got positive infinity. So let's pick a value in between negative infinity and negative 1. So let's try negative 2. Now, if we plug in negative 2 into this factored form, we're going to have negative 2 minus 3, which is a negative, over negative 2 plus 1 is still negative, and negative 2 minus 1 is also negative. So what would happen if I took a negative and divided by a negative times a negative? Well, this will be a negative divided by a positive, and we're going to get a negative number. So that means that it's less than 0 there. So since I got a negative number, I know that the graph should be underneath 0, actually. So let's extend this page a little bit, and let's try one from negative 1 to 1. Let's try 0. Let's go back up just a little bit so we can see this. So if I plug 0 back into this rational function, I'm going to get negative over a positive times a negative. And what do we have there? I've got a negative divided by a negative. That should have just been a negative. It's a negative 1, but I'm just doing signs there. And this means I get a positive. That means your rational function is above the x-axis from all the way from negative 1 to 1. All right, let's try one from 1 to 3. So let's try the value 2. And if I plug 2 in, I'm going to get a negative divided by a positive times a positive. And that's going to be a negative. So I know I'm below the x-axis from 1 to 3. And then from 3 out to infinity. So let's try 4. So if I plug a 4 in, I'm going to have a positive over a positive times a positive. And so that equals a positive. So I'm above the x-axis there. So let's answer the rational inequality first, and then we're going to show how this will help when we're graphing. To answer the question, when is this above 0, you're going to look at your sign chart. I'm going to say between negative 1 and 1. Notice I did not put brackets here because I don't have the or equal to underneath the inequality. And also unioned with 3 to infinity. Okay, so let's see how this is going to help us when we're drawing a graph. So let's go to the next page and see if we can actually draw this graph. So my original function is x minus 3 over x minus 1, x plus 1. Let's answer everything we can about this. This is our rational inequality. So let's do our horizontal asymptotes first. What's our horizontal asymptote? Well, if I have an x over an x squared, this is bottom heavy, so I know that I've got y equals 0 as a horizontal asymptote. Vertical asymptotes are going to be at 1 and negative 1. Those are x equals, by the way. X equals 1 and x equals negative 1. What about our zeros, our x-intercepts? The x-intercept, you always set the top equal to 0, so I have an x-intercept of 3. And the y-intercept is if you replace all of your x's with 0. So I would get a -3 over a -1 times a +1, and I would get a +3. So there's my x-intercept. I've got my y-intercept. I've got a horizontal asymptote, a vertical asymptote, two of them. And so let's take a look at our graph here. Alright, so let's draw a little axis, give me another line, see if we can't figure this out. Okay, so we go to our intercepts first. 1, 2, 3, 0, and then also 1, 2, 0, 3, and then I'm going to draw in my vertical asymptotes. So I've got a vertical asymptote out here at 1, and I also have a vertical asymptote out at -1. Get back to my line here. Okay, then I also have a horizontal asymptote of y equals 0. So I've already drawn the x-axis there, so don't need to do that again. This is my x, and there's my y-axis. Okay, so since on this side we've got an intercept here, but we also need to have a horizontal asymptote of the x-axis, I don't know if the graph goes, if it's up from 1 to 3 or if it's down from 1 to 3, but wait a minute. Maybe we do know. Let's go take a look at that inequality thing we did. This says the graph is below the x-axis to the left of -1, then above, then below from 1 to 3, then above. This helps you with how to draw your graph, so you don't have to do test points anymore. So from 1 to 3, my graph is underneath the x-axis. We know from earlier it touches at 3, 0, and it goes above the x-axis, but then it has to have a horizontal asymptote at y equals 0. So that means that our graph must do this. Go above for just a little bit and then settle back down to the x-axis, since we knew it was underneath from 1 to 3. And then what about in between this little sandwich here from -1 to 1? Is it above or below? We can tell from the y-intercept, but also you see it's positive, so that means our graph does a little U. It stays positive the entire time. So that helps me know that this does a U instead of go through. And then what about to the left of -1? Is it above or below? Well, we can go back to our little sign chart and see that it's underneath the x-axis, so it must be, do something like this. So the little inequality really helps us with our graphing as well. Now let's take a look at, I've got this graphed on the graphing calculator. Let's see how that looks. And there you have it. That's exactly what we have.